Welcome everyone to another interesting DSA problem which is titled as merge to sorted list. So let's try to understand what is the problem statement. You are given two linked lists, list 1 and list 2, which is already sorted. And what you are supposed to do, you have to club these two linked lists and make another sorted list. So here if you see by inspection, so you can see 1 is the minimum value, then followed by another 1, 2, 3, 4, 4. So this is how it's going to be sorted and going to give us the sorted combined linked list. So how can we do that? The class definition for creating a node in the linked list is already given, and from the method inside the class you can see that list 1 is optional list node and list 2 is also optional list node, and you are supposed to return another list node. So basically it tells us that there is a pointer which is already here at this point, which is list 1, another pointer here which is list 2. So we can use this pointer just similar to head, and we can try to solve this problem. So how I am going to solve this problem is that I am going to first create a dummy node. So that would be dummy equal to list node. If you wanted, you can give a value, else you can keep it like that. Then I am going to use another pointer which is current equal to dummy. So basically this is just a pointer somewhere here. It's like dummy, like 0, dummy. And what I am going to do, I am going to check while list 1 and list 2. Here initially list 1 and list 2 both are at the beginning point, both of them are valid. So we can have a check whether what value, if list 1 dot value is less than list 2 dot value, in that case what I am going to do is that whatever the dummy node which I created, that is right now another pointer that is not current pointer is pointing towards that node. What I am going to do in that case, I am going to start building from the dummy node. So that would be current dot next would be the list 1. Okay, list 1 is nothing but 1 here. Okay, and this list 1 will advance after once this has been utilized. List 1 equal to list 1 dot next. Similarly, if this is not the case, otherwise this would have been current dot next would have been list 2, and list 2 would have been updated as list 2 dot next. And once this is done, this current node should have been also modified. So in that case, let's erase it before, like this, like 0, 1, and the current initially was here. Then this should have been modified or updated to one of these places. So this would be the current pointer right now. So this should also be done. So current equals current dot next. Once this is done, it's fine, and it is guaranteed that one of them will get exhausted first. So whatever is going to exhausted first, it's fine. Whatever is remaining, we need to attach that to the current dot next. So once this while loop is over, then we need to check current dot next equals list 1 if list 1 is existing. Okay, else it's list 2, and at the end we need to return this particular pointer. This particular pointer is nothing but, if this is the dummy pointer which we have already initialized, this nothing but, this particular pointer is nothing but dummy dot next. So return dummy dot next. That's it. You will get a merged sorted list just by returning the optional node head. This will clear all the test cases. So what is the time complexity? If the list 1 has m members and list 2 has n members, the time complexity would be m plus n, and space complexity, we are not like creating a new node or something like that. Okay, like if you consider like building from list 1 to list 2 something, in that case you can take order of m plus n, but we are not creating anything, so it will be order of 1. So like if you think that this particular like linked list is creating separately, like separately, then it can, like in my opinion, it can be counted as m plus n. But if just somehow we are manipulating within this arranging from here to here or here to here, other than what is already existing, in that case it's like order of 1. So basically you can try to express your thought, that would be much more better. That's what I also understood by solving this thing. So that's all about this particular problem, and I hope you understood, and thank you for listening.